Science!
Okay, D-Man. So science this week. Another twofer. Two different stories from space. One is touching on one that we talked about a lot, and one is brand new. That one that we've talked about a lot, if you follow this show since its inception, one of the spacecrafts that we're really been monitoring ever since the beginning of the show is the Juno spacecraft that's been flying around Jupiter. It just made its 16th close flyby on October 29th, and we got some brand new images of that gas giant.
Oh boy, I love this stuff.
Yeah, and they are so cool. Now, you can view all of these images over at nasa.gov/Juno, and you can actually get all the mission parameters, see where it is in relationship to the planet. It's incredible. Juno was launched in 2011 and actually reached the planet in 2016. And like I said, once every 53 days, it does that close flyby over the planet, so we get some of these incredible photos.
It's so crazy. It must be moving so quickly.
So quickly.
I mean, Jupiter's so huge, and it's going around it and around it and around it. That's so insane.
Now, it gets to about 2,100 miles above the cloud tops, which is really close.
Yeah, I think.
Considering how close we are to Jupiter right now, I mean, that's really close. And it's already yielded so much incredible data just from being out there for a couple years and flying by every 53 days. Most recently, it has confirmed the existence of what scientists are calling wave trains. They're giant waves of clouds that appear in the atmosphere of Jupiter, some 6 miles high and over 700 miles long.
Giant waves of clouds?
Giant waves of clouds. Now, what we believe...
From what? Oh, you're about to tell me.
What we believe has to do with the gravity interacting with the atmosphere. Same way our cloud systems kind of work. So that's what we believe. Now, as Juno continues to gather data, we're going to continue to be able to peel back these layers. When we first sent the Voyager spacecraft past Jupiter in the 70s is the first time we saw this. And we were like, what is that? And scientists were like, they look like waves of clouds. Now, Juno is confirming that is exactly what they are.
That's so weird.
And it's really, really cool. So, I mean, you're going to get more of that. The last thing I wanted to tell you guys about Jupiter, which I think is really neat, is you can help NASA process all these raw images. All these raw images that you see in articles and stuff like that are directly from the satellite, they come back as raw data, black and white, huge photo files. If you guys are good at Photoshop or photo, manipulation, you can go to this website that I'm putting in the show right here, and you can actually download these files, process them, send them back to NASA, and they'll actually credit you on those photos, and those photos can be used in science journals and all sorts of other stuff.
So what are you doing with these photos when you download them?
Sometimes you're piecing them together to make them, a larger image, or sometimes you're at least cleaning them up, putting color. They're all black and white.
Yeah, right.
So you're putting color to them. You're basically taking the raw footage and making it something that looks nicer and is smaller and digestible for a blog or for your internet browser.
It's so nice of NASA to have us do work for them for free.
Hey, I mean, but if you love it, if it's something that you love.
Yeah, and if you get photo credit for something like that,
why
who
not?
knows? NASA calls you up and said, hey, we like the work that you did.
Exactly. Why not? I thought that was pretty cool. This next story is even cooler, and it's a little strange. The music of a Martian sunrise.
Ooh.
Now, a team of researchers used data sonification techniques from images of the Mars rover Opportunity to create the music. Angela Ruskin University's Dr. Domenico Vincenazza, I think I did all that right.
Sure.
And Dr. Genevieve Williams of the University of Exeter created the piece of music by scanning a picture from left to right, pixel by pixel, and looking at the brightness and color information. They used these algorithms to assign each element a specific pitch and melody. So the quiet, slow harmonies of this are a consequence of the dark background, and the brighter, high-pitched sounds towards the middle of the piece were created by the sonification of the sun's bright disk. Now,
so it's not literally sounds that the sunrise is making, it's an interpretation of photos that we have and how that would sound in certain frequencies.
Correct. And the idea of data sonification actually is helping lots of fields of science. There is a practical example of this that has been around forever, and it's the Geiger counter. The Geiger counter is what you use to measure radiation, and it's measuring those levels, but it brings them out as clicks. So when you hear more clicks, there's more radiation, and that is literally data sonification.
And same thing goes with a metal detector.
Exactly.
Yeah.
So this piece of music, which I'm going to play for you guys, is actually created from them assigning tones to the pixels in the sunrise from Mars.
I'm just picturing it's going to be a Kenny G song. Be horrible.
It's right here. So that's pretty cool. Like, that's the sound of a Martian sunrise. Now, again, it's a different type of science. I mean, it's not, exact science, but it's interesting to put music towards, data and then kind of, create something like that. Dr. Vincinaza said, "We are absolutely thrilled about presenting this work about such a fascinating planet. Image sonification is a really flexible technique to explore science, and it can be used in several domains, from studying certain characteristics of planet surfaces and atmospheres to analyzing weather changes or detecting volcanic eruptions."
How does that even work? So they're listening to it and they can, out of the sounds that are happening, they can kind of figure out what's going on?
Yeah, it can give them a better, in the sense where you take data and you plug it into a graph, you're getting a visual representation of the data of the ones and zeros that you're getting. You know what I mean?
Right.
So this is just giving you an auditory representation. So by using more of our senses, we might be able to extrapolate more from the data that we're getting.
So when are we going to get like the smelloscope?
I know, right? That's been in science fiction since I was a kid, right? Like,
what does Mars smell
what
like?
does Mars smell like? Fun fact, they say that the center of the universe smells like raspberries.
Really?
That's what science says. I don't know. But
why?
I don't know, but that's what they say. Because of the elements that are there, like the gases and the elements that are interacting at the center of the universe.
It smells like raspberries.
It smells like raspberries.
I heard gangrene smells like almonds.
This is quickly getting off the rails.
Science!
Science! I thought that was really cool. Again, we're always going to be checking back with Juno, and we're always going to be checking back with Mars. Thank gosh. InSight landed safely, and we'll be getting a lot of data from that as well. So happy science, everybody.